Hi there. Welcome to class. This is the Exam Readiness AWS Certified SysOps Administrator Associate. We're here today to talk about how you can prepare to pass your SysOps Administrator Associate exam and hopefully get a good idea of what the test is and what you need to study. I'm Blaine Sundred. I work with the AWS Training and Certification Department for almost 5 years, and we'll be excited to cover a number of specific topics. We're talking about the certification for SysOps Administrator as it fits into the larger view of the different certifications. You can see that we start out at the foundational level with Cloud Practitioner. This is not required before you take the SysOps Administrator course, but it's a good idea if you've never taken an AWS certification to take Cloud Practitioner, just to get an understanding of how the test mechanics work. SysOps Administrator is at the associate level. If you are successful there, you're welcome to go ahead and prepare and take the DevOps Engineer Professional exam, or try for one of our specialty certification exams, such as Advanced Networking or Security Specialty. The SysOps Associate course is broken up into 7 domains. Each domain is an area specific to the systems operations administrative tasks. Whether you're talking about monitoring and reporting, high availability, deployment, provisioning, storage, security, networking, automation, each one of these domains is important to systems operations. If you look at the percentage of the exam, you'll see that they're weighted differently based on each area. Monitoring and reporting is critical, so 22% of the entire weight of the exam is covered in monitoring and reporting, whereas only 8% is in high availability. We're going to go through each one of those domains and understand how they might actually appear in the exam. So we start by looking at, first of all, how do you understand what the question actually is asking, how to look through the different potential responses, to find exactly the best strategy to be successful in the exam. We'll also go through the content. Now, it's important to understand that for this course, we're not training you on the content. This isn't a SysOps Administrator course. It's to help you, if you already know the material, pass the exam. But we want to make sure that you know the material. So we're going to talk about each domain and point out some key elements that you should study, important information you should know, as well as how they might appear in questions. Here's some important tips, though, as you look at the test. There is no penalty for a wrong answer on these exams. If you don't know a particular service, but you've got an idea of what it might be, if you can rule out 1 or 2 of the possible answers, feel free to just flip a coin in your head. There's nothing wrong there's no penalty for getting a wrong answer. So take your time there. The most important thing we want to do, though, today is help you understand if there are any gaps in your knowledge. While this isn't the training course itself, you'll be able to go back to the website or some of our other training videos to help brush up on those areas that you might not be as strong on. This course is not a substitute for the rest of the training. It's designed to simply help you with the certification now that you know what you're doing. Let's dive in. Domain number 1, monitoring and reporting. In this domain, you are going to be creating and maintaining metrics and alarms in your system. This means you need to understand what those metrics do, how they're recorded, what triggers alarm states. You need to understand different types of alarms, whether you're talking about performance-based alarms or availability-based alarms, and then be able to do the appropriate remediation based on those different types. So with 22% of the exam on the line, let's make sure you know how to fix bottlenecks, how to monitor availability performance. Let's look at some key concepts and services. We start with CloudWatch. It's the metrics repository. So AWS puts metrics in the repository and you receive statistics based on those metrics. How do we get content into CloudWatch? Well, we start with the fact that pretty much every AWS service supports CloudWatch metrics. And they're going to push those metrics into CloudWatch. For example, running on EC2, you might get metrics on CPU utilization or status checks. You can also push your own metrics into CloudWatch. So, for example, you might want to push the page view count on your website, or even things like memory consumption, which is a function of operating system on EC2 and therefore not native to CloudWatch, but you can push that as a metric if you need. All these elements now in CloudWatch, what do you do with them? Well, first of all, now you've got statistics. And you can view those statistics either through the console or through any other third-party consumer. Or if the metric crosses a threshold, you can now enter an alarm state. Once you're in an alarm state, what next? Well, you could simply get notified through an SNS message, whether it's an email alert or a SMS notification, or it can actually trigger an event, such as a Lambda function or auto-scaling. Important features of CloudWatch. The types of metrics are very fundamental. A metric is a time-ordered set of data. It's published to CloudWatch. The metric is the variable. Namespaces are all these metrics that are grouped together, so certain types, certain services. And then the dimension is the name and value pair. The metrics are not continuous. This is a snapshot, a value in time. So we're looking at the period. How often are you collecting this metric? How often are you writing down the number? In the case of EC2, for example, standard metrics are recorded every 5 minutes. You can ask for detailed monitoring, which would allow you to record every 60 seconds. When you report a metric, it's at whatever period you want it to be. The alarm, when that number for that metric is either above or below the specific threshold you set for however many periods, however many minutes you want it to be. Of course, it's also important in CloudWatch to understand CloudWatch events and CloudWatch logs. Make sure you understand their use cases. Let's take a look a little closer at CloudWatch alarms. There are 3 states an alarm can be at. If it's in an okay state, that means the threshold is not exceeded by the metric. This does not mean that the system is fine. This is not a health, it doesn't have to be a health metric. It is simply saying that whatever threshold you're looking for with that number has not been breached. If you're in an alarm state, it means you've crossed the threshold. This can even be a good thing. You can have a custom metric based on total sales for the month if you want. That can be reported as a CloudWatch metric. Total sales just went over $1 million for the first time. You want it to be an alarm so you can let everyone know? Perfect. Alarm does not mean bad, just means metric over threshold. However, third state, insufficient data. You will get this from a SysOps point of view where the alarm doesn't exist. There's insufficient data itself, or maybe you're asking too often. You might be reporting every 5 minutes, but you're asking for the data every 30 seconds. In which case, because the data hasn't changed, you'll end up getting yourself into an insufficient data state. Make sure you know these 3 as part of the exam. CloudWatch events. This is a JSON object that's going to go ahead and explain what's happened. So you can pull down the JSON data and parse it out as you need. So you've got the header fields explaining what type of data is it being pulled, and then the individual details based on what actually happened. So in this case, there was an EC2 instance that was terminated. This is what you would see in the CloudWatch events. CloudWatch logs, parsing through log files, being able to create alarms off of those log files, means being able to parse the text, looking for specific elements. In this case, it's HTTP access logs, and we're looking for the 404 errors. Once the count, the number of times a log file hits a 404 error, crosses a threshold, let's say 10 times an hour. So you've got 404 errors coming in over a certain amount. You would like to create a support ticket. You'd like to alert the webmaster, someone to be aware that you're starting to get more than you would otherwise expect. You probably don't want an alert for every 404 error because some of them are people just mistyping a URL. But if you get consistent, this is where the log filters come in. Next, as you're talking about being able to trace and monitor what's happening, AWS CloudTrail. This records all calls to the AWS API system. We know who made the call, from where did they make the call, what time did they make the call, and what was the result of the call. So it's not just successful actions, it's also denied actions, so that you get a complete view of every call, every attempt against the system. The logs from CloudTrail automatically go to S3, at which point you protect them however you want to protect them. You can integrate CloudTrail with CloudWatch logs if you want automatic parsing of the content. This simply becomes an operational element to set it up. Now, to give you an example of a CloudTrail log where there was a failure, in this case, somebody tried to authenticate using the AWS console. They didn't have the right password. The information then comes back, and this is the truncated version, but it would come back, what time was this? Where were they logged in from? What was the IP address? And in this case, failure to connect. AWS config. This is the larger view, being able to monitor and report on the configuration of your resources. There's little information you get in config that you couldn't reconstruct by going through CloudTrail. But in many cases, people simply don't set up the analysis in CloudTrail to understand what's happening. So config will go ahead and keep track of the configuration history, who changed things, when, being able to look at the various states of the system, being able to report on the current configuration, were things changed, when were they changed. It's an easier view into change control. Those are the kind of services that you need to know as part of being prepared for this particular domain. Now let's take a look at some sample questions that you might run into inside the exam. Now, if this is your first AWS certification, it's important to understand that the structure is always multiple choice. In most cases, it is select the best answer. In some cases, you might need to choose 2 or choose 3. In those cases, it is very explicit as to how many you must get right. This is just a simple choose one. The first thing you want to do when looking at a question is to read the statement before you even get to the possible answers and take a look at the specific values inside that question that mean the most, looking for keywords. So in this particular question, some keywords jump out of the page at me. That you want to track the identity of all the users, that you want to see who's made a change to security group configurations, which service will then monitor and collect this particular data. Once you've found these key parts of the question, we call that the stem of the question, you now go through the different answers. And what you're looking for, first of all, are distractors. Possible responses that just don't work. So we start out by looking at option B, AWS Systems Manager. Well, we can eliminate B right off the beginning because System Manager is not a monitoring service. Option C, AWS Config, it's a plausible answer because it does deal with configuration. It monitors configuration changes. But config doesn't actually display who's made the configuration changes. And that's part of looking at the stem. We're not just seeing did it change, but specifically the identity of who made the change. So with that, that leaves us option A and D, CloudWatch or CloudTrail. Well, we eliminate CloudWatch because CloudWatch is simply metrics over time. It doesn't monitor. It doesn't go ahead and collect identity of anyone. The appropriate answer then, CloudTrail. This is the one that tracks identity. It knows about security group configurations. This is how we're going to monitor and collect the data. Next question. go ahead and take a look at this and try to find where the key words are in this sentence in the question before we move forward. All right. For me, the words that jump out are that this is an EC2 instance. It's sending metric data to CloudWatch in 5-minute periods. Now, to troubleshoot, you want to send the data in 1-minute periods. How do you accomplish this? So this is about actually changing the period for CloudWatch reporting. Well, let's go ahead and eliminate some distractors right off the beginning. So we look at B. From the EC2 console, modify the sampling rate attribute for the instance. There is no attribute called sampling rate. Therefore, we can go ahead and eliminate option B. We also can eliminate the idea of D, high frequency monitoring is not an element. And in the CloudWatch console, we don't modify the data collection period because the idea of metrics is it's a push. CloudWatch does not pull. So the correct answer, A. In the EC2 console, you'll enable the detailed monitoring for the instance. That's how you do it. Again, each service reports to CloudWatch. CloudWatch does not, in fact, initiate any of the metrics. Next question. This is an example of a select 3 option. So it's a test of the CloudWatch alarms, and the stem is real simple. You're looking for which statements are true for the alarm. Pick 3. Here's the important part. There is no partial credit for these multiple select options. The exam will actually require you to pick 3 and only 3 in order to consider this question answered. You must get all 3 right for credit for the question. All right, if we're looking for what's true, let's eliminate for what's false. And right away, I'm looking at option A as a false answer because in option A, the alarm can be created only with the CloudWatch console. Makes no sense because alarms data gets pushed into AWS, but also when you talk about can be created only with the console, that's also a red flag because remember, you can always do anything in the console through the SDK or through a CLI. So right away, A is wrong on a number of places. Let's go through a couple other ones. C, you can create an alarm that watches multiple metrics. No. CloudWatch alarms can only be done a single metric at a time, whether it's standard or custom. If you would like an alarm that is an aggregate of multiple elements, then you'll need to actually create that aggregate with another process that looks at those alarms and decides what the final state is. Let's see. What about option F? CloudWatch preserves alarm history for a month. This is where you really need to know the structure of CloudWatch. CloudWatch preserves alarm history for 2 weeks, not for 4. All right, that leaves us 3 choices. Let's go through and make sure we're happy with them. Option B, the number of evaluation periods for an alarm multiplied by the length cannot exceed 1 day. Sure. Option D, an alarm can be in 3 states. Okay, alarm or insufficient data, absolutely. And E, you cannot change the name of an existing alarm. Right now, that happens to be true. So if you want to have a different named alarm, you simply create a new alarm pointing to the same data. Next. Which of the following requires a custom CloudWatch metric to monitor? Now, the key part here is the word custom. We're looking for specifically elements that are not already tracked inside CloudWatch. So what are some things we can get rid of? Well, option C, going to get rid of that right away. Disk operation activity on an EC2 instance absolutely is tracked by CloudWatch. Option D, the number of connections not successfully established between the load balancer and the EC2 instance. This also is tracked by the ELB system. Finally, the total number of HTTP requests made by the Amazon S3 bucket. This is tracked also through CloudWatch and is available. Memory utilization is absolutely a custom metric when dealing with Amazon EC2. Now, if they were asking about RDS, that's different. In RDS, CloudWatch does record memory. But in EC2, because AWS does not have access to the operating system, memory utilization is custom only. Next sample question. A lot of stuff here, a lot of things to break down. Give yourself a moment, read through the question, see what parts of the stem jump out at you. So for me, I'm looking at CloudWatch. It's the second paragraph where all the meat of this conversation is. At CloudWatch, there's a 95% CPU usage on application servers, minimal memory usage, 20% CPU in the database with minimal disk operations. We're looking for options that can improve the response times in this stateless web application. So let's go through the different responses and find ones that can be eliminated. Right away, option D jumps out at me. Using auto-scaling to add additional application servers based on memory usage threshold, we've already pointed out that it's minimal memory usage. This is the exact opposite. Scaling on memory usage does not improve any response time. Option E, increasing the number of provisioned IOPS on the Amazon RDS database. Well, minimal disk operations is also mentioned. So this is not going to improve our processes. We're looking for two correct answers. So now we're just looking for one more element to eliminate. And the one we're going to eliminate is option C. There's no mention in the question that open TCP connections are the bottleneck. If this actually were the issues, then TCP connections be rejected. You'd see specific client errors, not so much increased response times. And even if this were the issue, increasing the number of TCP connections for servers that are already at 95% usage just overloads the instance. So what are the correct answers? Well, we look at option A to go ahead and choose a different instance type, or using auto-scaling for application servers based on their CPU load threshold. Pulling it all together for this domain. You've got to know CloudWatch. This is the bread and butter when it comes to monitoring and metrics. Also, understand CloudTrail. Know which metrics, which common metrics are native and which ones need to be produced custom. For example, custom, you've got to monitor the percentage of free memory on a server. As far as CloudTrail, you want to know who has launched an EC2 instance. These become the key questions when dealing with monitoring and metrics. All right, we have now covered monitoring and metrics. Our next domain is going to be high availability. If you have any more questions, though, about monitoring and metrics, make sure you check the website to get the information you need. Let's go ahead and move forward. Domain number 2, high availability. The idea here is to make sure that you, the systems operator, understand how to actually implement scalability and elasticity based on a variety of specific use cases. Also to understand the difference between a highly available environment and a resilient environment on AWS, and to understand the value propositions that drive different specific behaviors. What are the services you're going to need to know? Well, we start with Route 53. This is the DNS as a service designed to distribute traffic across regions. Some important things about Route 53 is you can register your domain names. It obviously resolves domain names to IP addresses. The number of routing options can be based on latency to endpoints or health checks or geo-proximity. There's a number of different ways you can choose to route the traffic. Make sure you understand what triggers are brought into play based on these different selections. Also, running in the same edge locations as Route 53 is Amazon CloudFront. In this case, it's a content delivery network. It's a CDN system. It can handle not only static, but also dynamic content, getting these endpoints closer to your actual consumers. This is not only optimized for high performance, for scale, but also for cost in many cases. Other ways to distribute traffic is important to understand when talking about high availability. The elastic load balancer comes in 3 different flavors, and you need to know the use case for each one because the question's going to change and the responses are going to change based on the type of load balancer in play. The application load balancer, this is flexible. It's HTTP or HTTPS, and it's designed to actually direct traffic based on the type of communication. It actually samples the packet itself. Whereas the network load balancer does no such thing. It simply takes all the incoming TCP traffic and just does a round robin to stateless web servers. This is great for performance, but not if you need any kind of evaluation. Or we still have the classic load balancer, useful for any of these other particular elements. It can handle both HTTP and TCP, but it won't necessarily do any evaluation of the content internally. The next tool you need to know for high availability is auto-scaling. I'm not going to go deep into the moving parts of the auto-scaling engine. You should absolutely know what a launch configuration is, what an auto-scaling group is, and understand the different triggers that can cause content to scale, whether it's simply a health check, it doesn't see a healthy instance, versus schedules, versus policies, or simply manually changing the desired capacity. Know the different properties of auto-scaling. You're absolutely going to see questions that are based on that particular feature. Let's take a look at some questions. First sample question. Big paragraph. Take a look through it. Find out the stem. Find the key elements before we go any farther. So for me, I'm looking at the idea that it's an auto-scaling group that is using an elastic load balancer. There's no specific distinction as far as what type of load balancer it is. So in this case, it either doesn't matter or assume we're talking about an ELB classic. New instances begin serving traffic automatically. That's great. After several days, you notice some instances are being marked unhealthy. However, the unhealthy instances are not being terminated. So what additional configuration is required so that auto-scaling actually terminates and replaces the instances the load balancer marks as unhealthy? This means understand the difference between how an ELB operates and auto-scaling operates. So, what can we eliminate? What are the distractors? Right away, I'm going to eliminate option A. Change the thresholds for the auto-scaling group health check. Well, first of all, there are no thresholds for the auto-scaling group health check. There only is health check type, which is Amazon EC2 by default. And again, you've got to know the moving parts of each individual service. Option B is incorrect because in this case, decreasing the unhealthy threshold is only going to cause load balancer to mark the instances unhealthy faster. It's not actually going to change how auto-scaling is handling the unhealthy instance. So you're just going to collect more and more unhealthy instances. Option D doesn't work. Changing the health check on the load balancer to use TCP instead of HTTP, while it changes what you're looking at, you haven't changed the behavior to actually terminate. How you change that behavior is option C. If you configure the auto-scaling group to actually use the ELB health checks, then when ELB decides an instance is unhealthy, auto-scaling will say, oh, unhealthy instance, remove it, replace it. That's how you actually get rid of the unhealthy instances from the group. Next question. Take a look. What are the key parts? For me, we're looking at a highly available connection between the VPC and your on-premises network. So how do you do this? This, again, is important to understand the moving pieces that are part of networking. So what can I eliminate? Well, first of all, Option B, creating a monitored connection by using the API gateway. There is no such thing as a monitored connection in API gateway. It's not a thing. In fact, the API gateway is not even a network connected solution. It's an application integration solution. Option C, incorrect. The AWS private link service is not a solution. Instead, it's just a highly available, scalable technology that allows you to privately connect to your VPC inside the network. But this isn't the solution to actually create the option. So this leaves option A and D. Take a look at them. Option A, direct connect. Option D, an AWS managed VPN connection with a virtual private gateway. Look at the question. We're looking for a highly available connection. So what we're looking for is that extra redundancy. And option A is a good choice, but you've got to make sure you eliminate single points of failure. And there's nothing in option A that confirms that you've eliminated everything, especially from your own on-premises network, where you could potentially have just a single connection. Whereas for option D, you are specific by saying with 2 customer gateways, you've got a highly available out from your building into AWS, which is already highly available in. Therefore, D answers all of the parts of the question. Cite this question. Take a look at it. Tell me what you see. For me, what I see is some key elements. Your website is hosted on 10 Amazon EC2 instances across 5 regions, globally distributed, 2 instances per region. We want to know how you can configure your site to maintain availability if one of the 5 regions loses network connectivity for an extended period of time. So we're looking for, first of all, which of the answers we can eliminate. We'll start by eliminating B. In this case, B, establish VPN connections between the instances in each region, rely on BGP to fail over. This is highly inefficient. There's a lot of extensive overhead. There's too much administrative effort. This is just not reliable. As we look through the other answers, option A, an elastic load balancer in front of the EC2 instances at an appropriate health check. That's great to do availability inside a single region. It doesn't work across multiple regions. Now, some of you might be saying, wait, there was a new feature released from ELB Network Load Balancer that it works across region if the VPCs are peered. Couple problems with that. First of all, there's no mention here that we're talking about the network load balancer specifically. And even if we are, that network load balancer still is centered in a region. And what happens if we lose connectivity to that region? So in that case, no matter how you try to spin it, option A is not a selection. Option C, incorrect. Route 53, using latency-based routing records that resolve to a load balancer in each region, set the health check on each load balancer. In this case, the elastic load balancing health checks do not directly influence Route 53's behavior. The only correct answer, Route 53 latency-based routing resolves to a load balancer in each region and has the evaluate target health flag set to true. Next question. Migrating an on-premises database to RDS for MySQL, you want to make it scalable across multiple regions. Which implementation choice do you use? Well, let's start by eliminating options, and immediately I'm going to eliminate option A, provision a multi-AZ database instance. That's a good suggestion, and that certainly increases availability. It doesn't increase scalability, and it doesn't do it across multiple regions. So nice, but no help at all. Look at option C, and let's eliminate it. Provision a database instance in every region. Use an AWS storage gateway instance to automatically synchronize data across regions. Storage gateway is a hybrid storage service. There is no function to synchronize data across regions. This is not a thing. Option D, create a database instance with an SSD-backed virtualized storage layer to automatically replicate data across regions. Incorrect. The SSD virtualized storage layer of RDS, that's only Aurora, and additionally it doesn't replicate data across regions, only across AZs in the same region. So the only answer that works is B, source database in one region, read replicas in the other regions. So some final things to think about when you look at high availability. Auto-scaling, elastic load balancing, CloudWatch. These are all designed to work together. They automate the addition and removal of resources based on metrics. It's important to understand that many resources inside AWS are already highly available. Services like elastic load balancing, S3, Route 53. Others can be highly available if you configure them properly. And for this, I'm looking at EC2, RDS. Also, understand the different types of load balancing options within a region using Elastic Load Balancer, as well as across regions, Amazon Route 53. All right, that finishes high availability. Next, domain number 3, deployment and provisioning. For this module, we're looking at identifying and executing the steps that are required to provision cloud resources, also identify and remediate deployment issues that come up with automation. There are 3 major services that you deal with when you're talking about automating deployment. You're talking about Elastic Beanstalk, AWS OpsWorks, CloudFormation. You need to understand where each one of these are the best choice for your particular business need. And we start at the beginning with Elastic Beanstalk. This is often discounted as a simple way to deploy without a lot of power. The truth is, while Elastic Beanstalk is very simple, and it goes ahead and handles all the deployment, it can take care of configuring your instances, can lay out the platform, it really shines when you look at it as a development deployment tool without a lot of additional effort. Because not only does it deploy your original infrastructure, similar to how CloudFormation might, but it also then can handle code updates, which CloudFormation has no concept of doing. So whenever you're talking about simple code updates, being able to automatically build scalable systems like web hosting, Beanstalk becomes a very good choice. Now, OpsWorks also allows for managed code updates, but in this case, you're putting a much more high-powered engine in play. OpsWorks can be done using OpsWorks Stacks, Chef, Puppet. In either case, you're going to be able to automatically provision new instances. It's going to take care of automatically healing stacks if for some reason something goes wrong. But in some of these cases, you need to understand Chef, you need to understand Puppet. I've had people ask, why would I ever use OpsWorks for Chef if I already have standalone Chef? And the idea is, again, eliminate that undifferentiated heavy lifting. It's the same Chef recipe, but OpsWorks takes care of managing the Chef server, taking care of those pieces that otherwise you'd have to manage on your own. CloudFormation, infrastructure as code. Having a single template that can go ahead and describe all the assets, all of their conditions, and then it can either create a stack from new, or it can update an existing stack, can delete a stack, and the execution then creates, updates, or deletes all of the resources. It's important to know it will only update or delete resources that have not changed manually since the stack was created itself. Great thing about CloudFormation, it is free to use. You only pay for the assets that it creates, and there's no cost difference than if you did it manually or your own scripting method. As you look at a CloudFormation template, it's important to understand the different pieces. Whether you're talking about like a wait condition that's going to that's simply going to count on its fingers in this case, because there is some process that's not going to report back cleanly. A wait condition is waiting for a programmatic report to come back. This is different than, let's say, a depends on condition. Make sure you understand how parameters and mappings work together to give you the proper variables you need inside your template itself. Let's take a look at how the questions actually appear. First question, take a look at the key, look at the key parts of the stem, then we'll move forward. For me, I'm seeing elements such as deploying the web application that must scale based on load. You've got application requirements, there's a load balancer, a PHP web server, database. The solution needs to automate application deployment, provisioning, and monitoring. Which services meet your requirements? Let's start eliminating some options. Right away, I'm eliminating option E. Cloud9. It's great. It's a development tool. It's an IDE. This has nothing to do with actually deploying the code. So you say, oh, D, code deploy? No, code deploy is only going to allow you to deploy code to an individual instance. It does not handle the deployment of the entire infrastructure. It is not a complete solution. 3 options left: managed services, OpsWorks Stack, Beanstalk. Get rid of option A. AWS Managed Services, it can deploy the cloud infrastructure, but it does not manage installation, configuration, or monitoring of the applications, just the infrastructure itself. What does that leave us? It leaves B and C, which in both cases, these can automate deployment, provision, and monitoring of the application itself. Next question. AWS CloudFormation template provisions the environment. It's got an EC2 instance and an RDS instance. The database must happen first. This is a common scenario. In this case, your application wants to connect to a running database as part of its launch. If it launches first but the database is ready, it doesn't know who to connect to. So how do you ensure that the database is complete before the instance launches? Which keyword are you going to use? Let's get rid of some ones that are wrong. I'm going to start by getting rid of option B, init. This takes care of actually installing the application and files, but there's nothing about sequencing that's part of init. Wait condition is wrong. Now, this is one you would think, oh, wait condition is going to be the right one. But in this case, all that's going to do is signal back that something has finished. It doesn't actually talk about sequencing itself. Outputs, not a solution. This is great if I'm going to launch another template later. It can return like instance ID of the EC2 instance in RDS, but doesn't answer the question itself. The one that does depends on. This is the solution we're going to use in order to make sure that once the RDS instance is complete, the EC2 instance depends on RDS checking in is done. You need to know the different parts of a CloudFormation for this section of the test. Next, you've been asked to update the resources in CloudFormation Stack. When you attempt to perform the update fails. When it tries to roll back, it's an update rollback failed state. What's the cause? What's a likely cause of the rollback failing? All right, what can we get rid of? We get rid of option B. An update causing an empty S3 bucket to be created that cannot be rolled back? No. If the bucket's empty, it absolutely can be deleted by CloudFormation. Next, let's get rid of both options A and C. The update caused new auto-scaling groups to be created that cannot be rolled back, or the stack's resources are part of an auto-scaling group that is scaled down. In both cases, none of that's going to cause a rollback to fail, which then leads us to option D, which absolutely can cause a rollback to fail. After the stack was created, something modified those resources outside of the CloudFormation process, which means CloudFormation couldn't find it, couldn't touch it, therefore it can't roll it back. Some final things to remember for this domain. We talk about Beanstalk. It's convenient. It's an easy way to deploy applications and to update applications. CloudFormation and OpsWorks can also deploy services. OpsWorks does the application stacks as well. And it's worth knowing a little bit more about how OpsWorks actually breaks things up into stacks and layers, how it can do different application layers. For example, the RDS can be in its own application stack. Get to know the moving pieces of CloudFormation. That's critical for good success. All right, that wraps up domain number 3. Domain number 4, storage and data management. In this domain, you're looking at how to create and manage data retention policies and operations, making sure you take care of data protection, encryption, as well as capacity planning. There are a number of key services in play, and we want to start inside the VPC itself. Inside the VPC with your EC2 instance, you're going to have elastic block storage. This comes in a variety of flavors. We're going to talk about those in a second. You also have instance storage that lives on the instance itself. It is not separate, not network attached. Understand the use cases for both of them. Understand how snapshots come into play. Then we look at what happens outside the VPC. And for this, we're looking obviously at S3 as the first one, and understand the different flavors of S3. Understand infrequent access, single AZ. Know how Glacier works. Understand the retrieval policies there, as well as the use cases for elastic file system. When you talk about backup and recovery methods, it's worth understanding the RTO and RPO solutions and which ones are going to provide the best time. Synchronous replication is going to be the best as far as recovery time. Asynchronous is still probably fast, but you don't have the same recovery point because now you've got data lost in transit. How much data? Who knows? That's part of what the operational question is. Snapshots are easy to implement, they're easy to operate, but that's going to be your slowest to recover and the potential for most data loss. It doesn't make it bad. It just means that you're going to have some other considerations when you look at snapshots. Let's take a look at S3. It's important to understand the characteristics of S3. It's highly available, 99.99% available, massively durable, 11 nines of durability. Any individual object at this point up to 5 terabytes of data in size. No cap on how much data is there. You are billed based on the content that is in the bucket while it is in the bucket and the amount of retrieval that it happens for that object. No cost to load the object. It's all API driven. It is not network connectivity. It is simply API and permissions. We look at Glacier. This is engineered for low cost, long-term backup, massive durability. So same 11 nines of data durability, has additional security controls in it, especially to prevent deletion. The key difference for Glacier, what makes it inexpensive, is retrieval times. It's not considered available as far as data retrieval. When you make the API request, standard retrieval, you're looking at 3 to 5 hours to get your data back. In bulk retrieval, it could take half a day. As long as your data needs, say retrieval can wait this time, Glacier is incredibly cost effective. It's not to say that you won't have the occasional unexpected need where you want it back in a few minutes. Expedited retrieval is available, but in those cases, it's very expensive to the point that if you're using expedited regularly, it might be cheaper for you simply to have left your content in S3 itself. Unless a question specifically talks about expedited retrieval, assume that any answer with Glacier is one that's going to be in multiple hours of retrieval time. That's not bad, just assume that's going to be what the case is talking about. Know the different EBS volume types. Now, I'm not going to read through the grid. You can pause this video here and look through all the different points, but understand about the general purpose drives, the GP2 on SSD. This is the most common drive that's used. Know right now where the caps are, the amount of I/O per second that can happen with this drive. If you need massive individual communication as far as number of I/O per second, that's where provision IOPS come in. If you're looking for how much throughput, then you might be talking about one of the throughput optimized ST1, or simply for cheap drives, SC1 becomes an option. If you need shared file storage, this is where Elastic File System can come in. Now, you can use S3 as a shared system, but S3 does not handle read-write block storage the same way Elastic File System does. If you want mounted file volumes, EFS is the solution. Let's take a look at some questions and see how they play. First question, what jumps out at you? You're looking at a way to archive documents for your company. They must be immediately accessible for 3 months, must be made available for 5 years, must be protected to meet compliance. What fulfills requirements in the most cost-effective way? Those are the big ones that jump out clearly, and right away we can eliminate option A. Use storage gateway to store data into S3, use lifecycle policy to move into Redshift. I'm not even going to mention whether storage gateway doesn't come into play. Redshift is a great data warehouse analytics solution. This is not low-cost, compliance-based archiving. A makes no sense at all. Get rid of option B. Direct connect upload data to S3 and then use IAM policies to move data into Glacier. I like that they're using Glacier, that's important, but IAM policies are permissions. They don't actually execute or move anything. Option C, wrong. Upload data into EBS, move the EBS snapshots into S3, and then later into Glacier. No, you can't move EBS snapshots in S3 to Glacier. That's not a concept. Also, why are we even using EBS in the first place? Option D is the textbook example. Upload your data into S3 directly, then use lifecycle policies, which again is very cost effective because it does not require any humans to do it, into Amazon Glacier for your long-term archive. Again, we're looking at just cost-effective compliance. That's Glacier. Next. Take a look, see what you see. Once again, storage solution for long-term retention of database backups. The backups must be rotated daily to a highly durable storage, and after 30 days, the backups can be archived to a less expensive storage solution to reduce costs. Some things you should be expecting right away on that, which means we can eliminate things like option A. Use instant storage for backups, copy to an EBS volume. There is so much wrong with option A. If you didn't laugh at option A being a solution, then you need to study instant store and what its use case is. Instant store is great for a lot of things. Durable backup, not one of them. The whole point of instant store, it's called ephemeral storage in the first place. Make sure you know that difference. Gonna get rid of option C. Use daily snapshots on an EBS volume to store the backup. I mean, that's good. That takes care of at least the first part in that you now have retention of daily backups. What you didn't solve was after 30 days, move them to a less expensive storage solution. So now we're comparing option B and option D. And they both start out the same. Use EBS to store daily database backup files, copy backup files to S3, and then option D goes off the rails. Use EFS file sync to archive files older than 30 days to EFS. EFS file sync does not transfer files from S3 to EFS. And even if it could, EFS is more expensive than S3 in the first place, even if you're using one zone infrequent access. The correct option is option B. It's got all the right pieces. EBS to store daily database backups, copy file to an S3 bucket, and then use your lifecycle policies to archive files older than 30 days into Glacier. Next question. What are we looking at here? It's a highly transactional database, it's mission critical, and you want the highest performance data storage solution. Pick an EBS volume type. right away, this should jump out at you. Highly transactional, highest performance. Cost is not a consideration here. We just want performance. So I'm going to eliminate the ones that don't matter. And I start with eliminating throughput optimized HDDs. Throughput is not my problem here. It's not the volume, it's how many individual transactions are happening. Cold hard drives, do not want them. General purpose is good for some solutions, but in this case, when you want the highest performance data storage solution, the provision IOPS is going to be that particular solution. Next. Which the following statements are true about encryption on an EBS volume? So here you've got to know the different pieces of EBS. We're looking for true. Let's get rid of what's false. And the first thing I'm going to get rid of is option B. To encrypt the volume, you must use the default master key of your account. No. First of all, there's all sorts of different options you could use for encryption. And there's multiple customer master keys. You could use KMS. No. I'm going to get rid of option C. You can attach an encrypted volume to any EC2 instance type. No, we have a number of instances that do not have the Intel Advanced Encryption Standard New Instructions, AAS-NI instruction. You want to make sure that you've got the right instance type so you can attach it. It's not to say you couldn't use operating system level encryption for any of these, but if you want the volume encrypted, only specific instance types. Which other one can we remove? Well, option E, because you cannot remove encryption from an encrypted volume. Once a volume has the encrypted property, it is always encrypted. The snapshots are always encrypted. If you want to make an unencrypted version of the volume, you basically have to decrypt the content and save it onto a new unencrypted EBS volume. What's left? Well, option A, which we just mentioned. All snapshots from encrypted are encrypted. And D, you can encrypt all EBS volume types. For example, wrapping it up. If you're looking through questions dealing with storage, look for keywords that automatically flag specific solutions. For example, anytime you see low-cost archive, that's Glacier. If you're looking for publicly accessible, that might be S3. As you talk about EBS, if you're looking for the most performance, that's provisioned IOPS. Understand the difference between ephemeral storage and instant storage, and also know the different types of pay structures, whether you're talking about EBS, where you provision and pay for what you provision in terms of number of gigabytes, versus S3 and EFS, that's a pay per consumption model. All right, we're done with storage. Next, domain number 5, security and compliance. For domain number 5, you need to make sure you can implement and manage your security policies, that you can do the access controls, and more importantly, that you can really understand and leverage the shared responsibility model, that you know where the AWS responsibilities lie and where you as the customer are responsible for particular tasks. You've probably seen this graph before. We use it a lot in AWS. The key part, the key takeaway from this is in any system running on AWS, there are portions of responsibility that AWS is 100% responsible for. AWS is responsible for the security of the cloud. You, the customer, become responsible for the security in the cloud. For individual services, the line may change, but there is always a line. Below the line, AWS is 100% responsible for maintaining control of those elements. Above the line, you, the customer, are 100% responsible for that security. In EC2, you, the customer, are responsible for the operating system. It's your job to keep it patched, to keep it up to date. In RDS, there's still an operating system. It's still running on an EC2 instance, but AWS maintains control of that operating system. It is our responsibility to keep it patched and keep it up to date. Understanding by service where the line is part of understanding the shared responsibility model. You need to know identity and access management, IAM. Two key parts to IAM. You begin with the idea of authentication, and then you control the permissions. Authentication, in this case, it's what type of credentials are being presented. Username and password, access key, secret key. When you look at, once you authenticate a user, now you look at giving them permissions. Just because you agree the operators who they say they are, it does not mean they've got the rights to do anything inside the account. This is an example of a IAM policy document that's going to allow the user to do whatever they want on EC2 against any EC2 asset, as long as they're using multi-factor authentication and as long as they're calling in from IP address 1234. Very specific, it's a /32. You don't have to be able to write these from scratch, but you do need to be able to read the JSON document that is part of an IAM policy. You need to know the different types of security credentials. If somebody is logging into the account, then they're going to log in as the root user, is one of the options. If they log in as the root user, that's the only time they're going to actually use an email address. We don't collect email addresses for any other of the IAM users. It's also important to know that the root user does not have any IAM policy associated with it, which means there's no way to restrict access. It's also one of the reasons we regularly make the best practice recommendation that root users should not be used in production because there is no way to lock it down or restrict it if for some reason the credentials get compromised. Normal IAM users, username and password, these have policies attached to them, which means those policies can be revoked if there's any questions about the security. If you're using the CLI or the SDK, in this case, it's not a password, it's an access key, secret key combination. But in any of the case, whether you're talking about the root user or you're talking about the SDK, you can enforce a multi-factor authentication where somebody must present a third-party token, whether it's a soft token on a phone or a hard token device. And without that, we do not accept the API request. It's also worth knowing a few of the other new security products like Guard Duty or Shield or Inspector. Understand where they fit into the model, how they actually help protect against intrusion, against DDoS attacks in the case of Shield, or in the case of Guard Duty. It's got machine learning process that looks through your environment for specific suspicious activity. Is somebody exposing credentials inside your S3 environment? You can actually have trusted IP lists it's going to look for, as well as threats you know against your business. Get to know those other services. They may show up on the exam. Let's look at some sample questions. Shared responsibility questions. Which ones of the following are not the customer responsibility? So we can eliminate the ones that are the customer's responsibility. And right away, option B, let's get rid of. Applying security patches to the operating system of EC2 is absolutely the customer's responsibility. Same with option C, configuring security groups for an EC2 instance. We need to eliminate one more option under A, D, and E. We're going to eliminate option D because in this case, setting up the IAM roles for an account, again, that's on the customer side. AWS does not set up the roles for those particular users and organizations. Now, option A and E. Option A, updating the operating system for an RDS instance. This is AWS's responsibility. The customer does not have access to this particular option. Option E, the access control list of a network device at the edge location. This also is a correct answer because out there in the edge, that's physical infrastructure. It's part of AWS. Therefore, AWS is the one that is responsible for configuring that particular asset. Next question. Which of the following services enables you to monitor AWS environment for suspicious activity and generate findings? This again is where it's important to know Shield, CloudWatch, GuardDuty, Inspector. Now, we're first going to eliminate option A, AWS Shield. A Shield is great. It takes care of DDoS attacks, but it's not, again, about generating findings. It's not a monitor system. Now, CloudWatch is a monitoring system, but doesn't monitor for suspicious activities. It also does not generate findings. D is also incorrect. Inspector is an assessment tool, but it's not a monitoring tool. In this case, we're looking at making sure that we generate the findings, that it constantly monitors for suspicious activities. This is, in fact, the use case of GuardDuty. It's going to take care of analyzing flow logs and CloudTrail event logs and DNS logs, looking for this kind of malicious action. Next question. You've got an S3 bucket policy. So what is true about this particular policy statement? So first of all, we break it down. It's an S3 get object. It's going to allow against which resource? Well, it's a particular S3 bucket and only files that end in .xml. And the principal is star, meaning it's going to allow it for everyone. So what can we get rid of? Well, first of all, I want to get rid of option C. The idea of denying IAM users in a bucket, in the bucket owner's account access, it's not a deny policy. This is only about, it's only an allow policy, so right away, C makes no sense at all. I want to get rid of option A. It grants read access to XML objects to users in the bucket account only. Because the principal is asterisk, it's a grant to everyone, which takes us then to B or D. Is it grant everyone read or grant everyone read and write? Well, it's not option D. It is not read and write because in this case, if you look at the action, it is S3 get object, which is only the read access permission. Therefore, B is the correct answer. Next question. Writing a script. It's going to run on the EC2 instance at boot time. This is going to publish data to CloudWatch metric using the CLI. It's looking at the put metric data CloudWatch command. What is the most secure way to ensure this script has the proper permissions to execute the command? So this requires understanding how metrics get put into CloudWatch, how to properly secure them down. I'm going to get rid of option D right away. In this case, you're asking you to modify the CloudWatch policies. Okay, that's fine. You can do that, but you haven't finished. You actually need to assign that policy to something, a user, a group, a role. Option B is wrong. Create a user that allows the CloudWatch metric, put metric data action. Use the user to launch the Amazon EC2 instance. The fallacy here is a transitive property of permission. There is no transitive permission. Just because the user had the permission to do something, that never translates then to any object they create. Every object has to have its own permission set. Option C is eliminated. It actually might work. You could create a user that allows the actions and then embed those users' credentials into the configuration script. But in this case, that's not secure. And one of the questions is, what's the most secure way? So the most secure way is option A, and this is the textbook answer. You create a role, the role allows the action, you launch the instance into that role, and that way when the action is executed, the instance has the credentials to execute that, but those credentials are temporary, hence more secure. They automatically rotate every 30 minutes. Roles, putting it all together. First bullet point, roles are often the most preferred method when you look at the general cases. Because of that rotated credential, because it can be assumed, when given a choice, almost always roles becomes a good answer unless you're looking for permanent credentials that are maintained by the users themselves. Large number of users, not recommended. In fact, there's a maximum number of users in any particular account. Better solutions are identity federation, tapping into your Active Directory solutions. Understand security groups and network access control lists and how they play together also for security is important. Understand where your accept and deny rules come into play. All of this comes into the security conversation. All right, we're done with security. Let's take a look at networking. This is domain number 6. Networking, it's almost 15% of the exam. It's significant. You need to be able to understand the different networking features, understand how to connect hybrid modalities into AWS, how to troubleshoot any problems inside the network. This is not an operations class. We could talk for hours about understanding the different pieces of AWS networking. You need to make sure you know it cold. You need to understand how VPCs are created, how they straddle multiple availability zones. You need to understand subnets and security groups, access control lists inside the subnets. You need to understand gateways, such as the internet gateway, the virtual private gateway, peering connection gateways, and know how they get connected to the route tables, and then how the route tables are associated with the subnets themselves. What makes a subnet public is not the label. You can call a subnet anything you want. You can call it man-bear-pig. It doesn't change the performance of the subnet. It's only, is there a route table with an IGW, and is that IGW associated with the subnet? That's what makes a subnet public. We talk about connectivity options. This is my hybrid discussion. You need to know how Direct Connect works, how it plugs into your on-premises data center, how it goes through a virtual private gateway, the VGW. Also, the AWS managed VPN connection, going again through a customer gateway on the customer site. That's different than a peering connection. The peering connections do not go through the VGW. Instead, you can handle multiple VPCs over private IP that can also be multi-region now, not just single region. Understand the different options when it comes to network address translation, your NAT servers. Used to be you always had to host your own NAT instance. A couple years ago, we announced the NAT gateway, where now there is NAT as a service. In either case, it still runs inside your VPC, still managed there. Know how this can be used to allow private instances to still get updates out of the internet. As you talk about private instances, sometimes they need access to S3 or Dynamo or other services that are outside of your VPC. In that case, understand how VPC endpoints can actually connect to those assets. Used to be that if an instance wanted to talk to S3, it either had to have a public IP and be in a public subnet, or you had to have a NAT instance. Now with VPC endpoints, you can actually make that connection, put that endpoint into a route table, associate that route table with a subnet, and then those instances can talk directly to those services. As you look at the large picture of security and how network comes into play, we think of protecting an EC2 instance like an onion skin, a whole bunch of different layers. And the very first layer is the idea of the route tables, because the route tables control the gateways. And if you don't want someone from the outside talking to your instance, then you simply change the route table so it's a private subnet. You cannot hack from the outside what you cannot touch, and the route table protects that. The subnet itself can have deny policies, both inbound and outbound. The security groups can then also control inbound and outbound traffic, as well as simply having operating system host-based third-party protections, intrusion detection systems, intrusion mitigation systems. All of these are successful at blocking attacks. So which one should you use? The answer is yes, all of them. There's no reason not to use all of these pieces, so that if for some reason anyone makes an accidental or intentional change to one of these layers, there are other layers that are still providing protection for your resources. Make sure you understand the way security group and network access control lists communicate with each other. In this case, the security group is stateful. Any communication that is already allowed into the instance, the response traffic is allowed. Any communication that is initiated by the instance, again, the response is allowed in. Network access control lists. This, again, can be used to control traffic in and out of the subnets, but this is stateless. Just because traffic was allowed in does not mean response traffic can be allowed out. You can actually enforce almost a UDP-style traffic this way by only allowing inbound and allowing no outbound traffic, or vice versa. Troubleshooting. You've got instances in different subnets that for whatever reason can't communicate with each other. What are the steps? Well, the first step is make sure it's not an instance issue. Make sure that both instances are alive and healthy. If you're trying to communicate with an instance that was stopped for some reason, guess what? You're not going to be able to talk to it. Then go ahead and check the network ACLs, check the security groups, check your flow logs to see where the traffic's actually going. Problems with the NATs, there's NAT configuration issues. Well, in both cases, if it's a NAT instance or a NAT gateway, make sure you've got the right route table association, that the route table is associated with the subnet. And if it's a NAT instance, go through your checkboxes. Is the source destination check disabled? Does the NAT in fact have masquerade already configured? Bounce the NAT. Do whatever you need. It's normal EC2 troubleshooting. Let's take a look at some sample questions. Give it a look. What are the key parts? What's the stem? It's a web application. You need to ensure high availability. So it's across two availability zones. What VPC configuration meets the requirement while preventing direct access to the database? Time to cross off some wrong answers. And right away, I'm getting rid of option A. One public subnet, one private subnet, it doesn't meet the requirement of high availability. In fact, that's the same reason I'm going to get rid of option B. Two public subnets, one private subnet for the database. Without two of each, you're not going to be able to actually solve the high availability question. Now, both C and D both have 2 and 2, but take a look at the actual types of subnets. Option D, 2 public subnets and 2 public subnets to host the databases? No, we want the databases in a private subnet so they cannot, in fact, have direct access to the internet. That is option C. Next question. Creating a VPC, 1 public subnet to run an EC2 instance that's accessible from the internet. This is a very simple architecture. Which of the following, pick 3, must be configured to satisfy this requirement? Okay, so what are we going to get rid of? We'll get rid of option B, the VGW associated with the VPC. A VGW is fine. There's no need to actually create that if you need a publicly accessible instance. Next, option E, a subnet with a /64 IPv6 CIDR block. There's no need for this. Even a /24 IPv4 CIDR block is going to work. It doesn't have to be IPv6. That's an arbitrary element. You want to get rid of option F. A second ENI does nothing to satisfy the requirement. It might be used for any number of other requirements. It doesn't come into play here. This leaves us public IP address, yes. Now notice, it doesn't say an elastic IP address because that would not be required, although it could satisfy part of the requirement. In this case, a public IP could be AWS provided, could be an elastic IP. That solves the problem, but you must have a public IP. Option C, you must have an IGW, and option D, a route from the subnet to that IGW. A, C, and D make the correct answer. Next, you're setting up an AWS managed VPN connection. Which of the following components must you create? Let's go through them. It's not going to be option B. A public VIF is a direct connect function, not used as part of an AWS managed VPN connection. Again, this is important for you to understand the different moving pieces in direct connect as well as VPN. Next, I'm going to get rid of the NAT gateway. It's a device that actually allows private subnets to connect to the internet, which is not part of our conversation here about the VPN itself. The VPC endpoints are great to allow your instances to talk to S3 or something, or supported services. Not part of this conversation. What is part of the conversation? You must have a customer gateway on your side, and you must create a VGW on the AWS side. A and E make the correct answer. So, next one. Again, it's another pick two. Two instances, two different subnets, same VPC. They can't ping each other. So what are my troubleshooting steps? Well, right away, I'm going to get rid of option C, an IAM policy that allows ping operations. IAM does not control network operations. Ping is not an API. It makes no sense. Next one to get rid of. E, check security groups are assigned to allow TCP traffic. Ping is not TCP. Ping is not UDP. Ping is ICMP. So in this case, whether you're allowing TCP or UDP makes no difference at all. Which other one can I get rid of? You're going to get rid of option B. We don't worry about making sure there's a route between two subnets in the VPC. There is always the default routing line that ensures any instance inside a VPC, whatever subnet they are, can talk to each other. It doesn't mean there's not going to be access control lists or security groups that could block it, but there certainly is not a route problem. So what could be my two concerns? Well, we just talked about it. Option A, a security group rule. Make sure it's got ICMP that's allowed. And D, the network ACL, that both subnets have rules that allow ICMP to move back and forth. Putting network together. A number of key things it's important to know. Network in and out of an EC2 instance is often controlled by how large the instance is. A larger instance within a particular family often means greater network bandwidth. Know the moving pieces of Direct Connect and AWS Managed VPN. The Direct Connect is going to have the private and public VIFs. The AWS Managed VPN is also going to use the customer gateway at the customer's ends. In both cases, the VGW takes care of connecting it to AWS. That's it for networking. Let's take a look at domain number 7, automation, optimization. So for domain number 7, in this case, AWS, how are you going to use AWS to manage and then assess resource utilization? You need to make sure that we take care of cost optimization strategies, as well as making sure you're optimizing all of these manual, repeatable processes in order to minimize management overhead. There are a lot of services in play when you talk about automation. Many of them we've already talked about. CloudWatch, Trusted Advisor is an important one that's going to be a key element to let you know about limits and certain types of optimization strategies. In fact, when you talk about cost optimization specifically, Trusted Advisor becomes a great way to point out when you've got instances that are run that aren't being used or that are too large, unused elastic IP addresses. Cost Explorer, Lambda all become additional functions you can use to tune your system. Looking at automation, again, we've talked about some of these. CloudWatch, Autoscaling, CloudFormation, OpsWorks. Understand how Systems Manager is able to also improve your operations. And don't forget to use step functions as a way to simplify the management of workflows. Little closer look at Trusted Advisor itself. In this case, you can go ahead and fire it off or automatically have it fire off, and it will go through over 50 checks if you are part of the business or enterprise level support. looking at things like service limit, whether you're approaching service limits, security problems, fault-tolerant problems, cost optimization, going through a number of these specific checks designed to help you make good decisions. It's not going to change anything, but it's going to alert you when you're either approaching or crossing certain thresholds. Lambda is an excellent cost optimization strategy, especially when you talk about compute, because when you look at Lambda, it is pure consumption compute. You only pay for the microseconds that you're actually processing code. Other key things when you look at cost optimization, making sure that you've got properly sized instances. Don't run the super jumbo instance when a small is going to do the job just fine. And in many cases, running many small instances, even though it might have the same capacity as one or two very large instances, you're going to be able to more optimize with the small ones because of the granular nature of the tasks. Turn off the lights, turn off your unused resources, use Trusted Advisor. Use tagging. As you look at cost management, most assets inside AWS have tagging structures where you can go through and identify individual instances, individual objects. Are they part of your development team? Are they part of your production team? Are they part of a research project? And then you can bill back accordingly to these different departments. Cost Explorer is going to allow you to understand and manage your costs by giving you good visualization of what's actually happening across your different assets, across your different departments. Also allows you to actually define and track budgets. It's a good cost forecasting engine. Being able to use Cost Explorer is again part of your automation process to manage your actual spend. Systems Manager. This is your management system. It's designed to collect your software inventory. It'll automatically apply operating system patches. It'll save off system images. It will even take care of operating system management and configuration. This is kind of a one-stop shop to take care of all these little fiddly bits without worrying about setting up complex chef recipes or Puppet processes. Get a chance to play with System Manager before you take the exam. There's a lot of important things that it does as far as optimizing your operations. And we did talk about step functions. Again, this is something else that can be used to automate processes. In this case, workflows. If you're building a complex workflow system or even a simple workflow system, step functions takes care of controlling state. You don't have to worry about programming a separate state process through a NoSQL database or other options. And of course, it integrates very easily with Lambda to handle part of those functions as part of your workflow. Let's take a look at some questions. Break this one down. What are the key things you see? For me, what jumps out is you're wanting to verify that the storage usage isn't more than 80% of a total storage quota limit. It's a very unique question, which is going to actually rule out a bunch of things. First thing it rules out is option A. The CloudWatch console check the value of free storage space is less than or equal to 20%. This would only make sense if the total volume was exactly correct. That doesn't come into play when you're looking at total storage quota limits. The two don't come into play. Option C, incorrect. AWS config has no default managed rules that can check that database usage is 20% or more under a quota limit. It's not an option. D, inspector, incorrect. I mean, Inspector's great. It's an automated security assessment service. It does not deal with storage quotas. What does? AWS Trusted Advisor. This is where you go to check quota limits, including, is your usage more than 80% of your RDS storage? Next question. What do we see? Got a batch workload. This workload is flexible from a timing standpoint. It's designed to be restartable. That should jump off the page at you. Which purchasing option of EC2 instance is the most cost-effective way to run the workload? Anytime you see the word most cost-effective, right away you can eliminate option A unless you have to have it be on demand. In this case, don't need it. Reserved instances are great and can be cost-effective, but in this case, because we're flexible from a timing, it's a batch workload, which means it's going to be on and off. Reserved instances are not good because in this case, that's for consistent heavy workloads. Now, scheduled instances, again, are good if you can handle workloads that are specified recurring schedules, but in this case, we're flexible. We don't have to reserve that. Flexible, designed to be restartable, most cost-effective. That's the definition of a spot instance candidate. Next question. You want to use System Manager to deploy regular updates in a group of Windows and Linux instances, launch with AWS provided AMIs. What do you have to do to achieve this using System Manager? This means you've got to know System Manager. Remember I told you you know it? Hopefully you know it. If you don't know it, pause right now, go and find out, and then come back and answer the question. I'm going to answer it anyway. Here we go. It's not option B. First of all, you don't need to install the AWS System Manager agent because you're using AWS provided AMIs. The agent is not needed in this case. Already comes pre-installed. You don't need option C. Configure it using a private link interface to your VPC. You don't need to have this set up for System Manager. The instances already have outbound internet access. No problems needed there. Next, get rid of option E. Apply the AWS System Manager patch update run command. Syntax, the API name, none of this is correct. That's just not a thing. What do you need to do? You need to do option A. Write your own System Manager documents in JSON, apply it as an automate document, define the versions, use the automate tool, and option D, create the instance profile for System Manager, attach it to the instances. Cloud. Final thoughts on automation. CloudWatch, autoscaling, Lambda can all manage your resources in automated functions. You always want to look at solutions that treat infrastructure as code. CloudFormation, OpsWorks, Elastic Beanstalk. You want to understand how Trusted Advisor works. Know how it's especially good anytime you're talking about quotas. See the word quota? You can almost guarantee Trusted Advisor is a correct part of the answer. All right, that takes care of automation. So let's wrap it all up and put it together. As far as preparing for AWS certification, preparing for this one specifically, hopefully everything we talked about today just made sense to you. That you understood the questions, you understood the answers, understood the various services we talked about. In which case, you're probably ready to go take the certification right now. If there were points that confused you, that you go, what is Blaine talking about? Then that should be a flag that that's where you need to take extra study. And if you want to study the whole thing, please feel free to take an actual in-person instructor course. AWS offers, from both us and our partners, classes on system operations and many other topics. No matter what you do, take the time to go to aws.amazon.com/certification and take a look at the exam guides itself and look through the different white papers and specifically go through any documentation and reference architectures so you understand the kinds of questions that come into play for the Systems Operation Associate exam. I hope you learned something good from today's lesson, and I hope you have great success in your certification. For AWS Training and Certification, I'm Blaine Sundred.